Hey, and welcome back to Learning Python, your first step to data science. We're back with a different chapter now, having progressed through the importing datasets bit. And now this time I want to talk to you guys about how we can visualize data with Python. And the first step for us to go through in this video is how we can use third-party packages like seaborn and pipenv to visualize data in Python. So, once again, we are in Jupyter Notebook. I am in chapter 2.ipynb, and this is the chapter 2 Jupyter Notebook that is present in your accompanying code files. Here, our chapter focus is visualizing summary statistics on our datasets. And in this video, we are going to visualize data with third-party packages. As you can imagine, like most things in the Python world, whatever common use case you can think about has an existing package that can do that thing very well. So let's first import and look at some of these packages that are relevant to us today. In in15, I'm first putting in the command %matplotlib inline. A percent is a character that signifies to IPython or Jupyter that we're giving the interpreter or the kernel a new command. And this command relates to the package matplotlib, and specifying inline as an on flag means that when we import the matplotlib later, it will start plotting the moment we call plots, and calling plot.show is optional. So in in15, we continue by first importing matplotlib, which is a Python library standing for Mathematics Plotting Library. And within this library, we're importing .pyplot, which is the Python part of this library. And we're importing this as a shorthand PLT so that we can minimize our typing. The second package we're going to import is NumPy. So we do import NumPy as NP, again as an abbreviation to save on typing. And lastly, we import our old friend pandas as PD, again to save time. To demonstrate any sort of plotting application, we first need some dummy data. In in3, we're creating two variables, x and y. In x, we're using NumPy to create a linearly spaced dataset, which starts from 0, ends at 10, and persists for 1,000 data points. To create this dataset, we call the NumPy function linspace, standing for spaced points linearly, which goes from 0 to 10 with 1,000 data points. For y, we're first creating a matrix of random numbers using NumPy, so np.random.randn, and then we feed in the two dimensions of this matrix, 1,000 and 6. And then we further wrap a cumulative sum function, np.cumSum, over this matrix. After we've got this random and dummy data, we can proceed to plot this data out. In in4, we're calling plt.plots, feeding in x and y, and then calling plt.show to show this charts. As you can see, the 6 time series or random walk series of data appears on the graph no problem, is a line graph. There are colors to distinguish between different series, and that's all well and good, but it doesn't look that nice. So today on this video, I'm going to show you a shortcut which allows us to still use the function calls that we know and love from matplotlib, but make it look a lot prettier. Enter seaborn. Seaborn is basically a package that's built on top of matplotlib. And so here in in5, we're importing seaborn as SNS, and we're calling the function to prepare seaborn sns.sets. The next thing to do is again plot the data as normal. In in6, we call plt.plot x, y, like what we've done before, and again we call plt.show. As you can see, immediately seaborn gives us a plot that looks a lot more respectable visually. We still have the same features, but the colors are no longer as ugly. And we can see that there are additional features like grids in the background. Now seaborn is a lot more capable than this. For example, if we want to plot two histograms on top of one another, we can look at in8. In in8, we first create some data. In the data variable, it is assigned to a pandas data frame, which consists of two columns of 1,000 data points. That's created randomly by np.random.rann. We call these columns A and B by feeding a list that contains the characters A and B into the column's keyword argument. Then, for each dataset in the list AB, we call the hist function to plot a histogram on the same canvas. So here we call plt.hist, feeding in the data which is subsetted by the column that we want. We want to normalize this data, which is why we put normed equals to true, which allows us to normalize the data. And because we want each graph to overlap but still show up in the graph, we set the alpha or the transparency to 50% by setting the number at half. One more call to plt.show later, we can see that we see a very perfectly normally distributed datasets showing up on our plots. Not only can seaborn plot histograms, it can also plot smoothed histograms, also known as kernel density estimations. The function to do this is kde plot. In in10, again we create a for loop for datasets in AB, and we call, instead of plt, sns.kde_plot, which is a unique function to seaborn, and we feed in the relevant columns in the data frame. We want to shade the area below the curve, which is why we feed in a keyword argument of shade, setting it to true. Another plt.show call later, we can see this new kde plot showing up on our screen. To combine a histogram and a kde plot, we can use the function sns.distPlots, standing for distribution plots. In in11, we call sns.distPlots, feeding in the A column of the data. In out11, we can see that we have a diagram, which consists of both our histogram and the KDE smoothed curve. So having done that, in the next video I'm going to talk about the topic of how we can explore datasets using pandas in Python. Stick around and I'll see you guys in the next video.